Assalamualaikum. Welcome back to Sir K Lab's Physics and Chemistry tutorial for high school students. In this episode, we look at two problem applications of Newton's law of acceleration. One of these is on circular motion, and the second problem is an excerpt of a past upload on Hooke's law. So just hang on, watch and learn. Question number 1. In one version of the giant swing at a country fair, the seat is connected to two cables, one of which is horizontal. The seat swings in a horizontal circle at the rate of 28.0 revolutions per minute. If the seat weighs 255 newtons and an 825 newton girl is sitting on it, find the tension in each cable. Based on this figure, the girl and the seat are actually swinging in a counterclockwise manner around this solid vertical post, okay, with an angular speed equal to omega, which is 28.0 revolutions per minute. The length of the horizontal cable is equal to 7.50 meters. So this length happens to be the radius of the circular path taken by the swing. That means by the girl and the seat. All right? And the combined weight of the girl and the seat, of course, is 255 newtons plus 825 newtons, which is 1080 newtons. So again, in the diagram, we can identify the forces acting on the girl and the seat. All right? We have the force exerted by the diagonal cable labeled here as T sub 1. All right? So this cable is pulling the girl and the seat in that direction, indicated by the vector arrow colored red. All right? So this diagonal cable happens to form an angle 40.0 degrees with this vertical post. And the force exerted by the horizontal cable is labeled here as T sub 2. And of course, the weight of the girl and the seat combined labeled as WT and represented by the downward arrow. And our target variables are T sub 1 and T sub 2. All right? So our solution starts with getting the y component of T sub 1. All right? Since T sub 1 is directed along this diagonal cable, it has a vertical or y component directed upward. All right? And also a horizontal or x component directed to the right. And for the vertical component of T1, we label that here as T sub 1y. That's simply equal to the combined weight of the girl and the seat, equal to 1080 newtons. Since there are no other forces or vertical forces acting on the girl and the seat. All right? And using the cosine function, we can also express the magnitude of T1, all right, as T sub 1y divided by the cosine of the angle 40.0 degrees. Right? You will notice that the y component, t sub 1y, all right, with respect to the angle of 40.0 degrees, that happens to be the adjacent side of this triangle. All right? That's why we use cosine of the angle 40.0 degrees. So substituting the value of t sub 1y, which is 1080 newtons, and divide it by the value of the cosine 40.0 degrees Celsius, all right, using your calculator, we will get the value of t sub 1 equal to 1410 newtons. All right? So the direction of t sub 1 is as shown in this figure. We convert the angular speed omega, 28.0 revolutions per minute, into its radian per second equivalent, simply by multiplying it by 2 pi radian per revolution and by 1 minute per 60 seconds. So doing our math, we get 2.93 radians per second, right, as the value of the angular speed omega. So using this value of omega, we can now compute the tangential speed v using the formula v equals omega times r. That is 2.93 radian per second, which is the value of omega, times 7.50 meters, which is the value of the radius r. And the result is 22.0 meters per second as the value of the tangential speed. All right, we also compute for the horizontal component of t sub 1. We label this here as t sub 1x, and that is equal to t sub 1 times the sine value of 40.0 degrees. Substituting, we have 1400 newtons as the value of t1 multiplied by sine 40.0 degrees, all right, and we get the magnitude of t sub 1x equal to 906 newtons. Emphasizing the tangential speed v, the horizontal component of t sub 1, and the combined masses of the seat and the girl, we can now apply Newton's second law, or the law of acceleration, all right, which says that the net force acting on the seat and the girl on the swing is just equal to the centripetal force mv squared over r. The net force is just the sum, or vector sum, of t sub 2 and t sub 1x, right? Or that is t sub 2 plus 906 newtons equals 110.2 kilograms, which is the combined mass, right, times the square of the tangential velocity or speed, 22.0 meters per second. Then divide the whole thing by 7.50 meters, that's the value of r, all right, and solving for t sub 2, all right, we transpose and isolate t sub 2, so we shall get this simplified equation, T sub 2 equals 7,110 newtons minus 906 newtons, or the value of the tension force T sub 2 equals 6,200 newtons. For our question number 2, this is the last question. A steel cable with cross-sectional area 3.00 centimeters squared has an elastic limit of 2.40 raised to the 8th power Pascal. Find the maximum upward acceleration that can be given a 1,200 kilogram elevator supported by the cable if the stress is not to exceed 1/3 of the elastic limit. Before we can find the value of the maximum acceleration of the elevator, we first find the tension force exerted by the cable on the elevator using this formula. All right? So the perpendicular force referring to the tension force in the cable is just equal to the amount of the stress multiplied by the cross-sectional area. And the amount of stress that we're going to consider here is the elastic limit mentioned in the problem, equal to 2.40 raised to the 8th power Pascal. Multiplying that by the cross-sectional area, already in meters squared, 3.00 raised to the negative 4th meters squared, that is. All right, we will get the amount of this force or tension of the cable equal to 7.2 raised to the 4th power Newton. We can then apply the law of acceleration formula, A equals F net divided by the mass, where the net force is the tension force, all right, minus the weight of the elevator. And then we divide this net force by the mass, the elevator. And the tension force in the cable is, according to the problem, should not exceed 1/3 of the force that we got in here. 1/3 of 7.2 times 10 to the 4th power Newton, which is 2.4 raised to the 4th power Newton. Then we subtract the weight of the elevator, that is 1,200 kilogram, times 9.8 meter per second squared, and then the net force is divided by the mass of the elevator, 1,200 kilogram. So doing our math, we will get the maximum value of the acceleration equal to 10 meters per second squared in two significant figures. All right, so this is the maximum value of the acceleration that the elevator can have, so that the force in the cable will not exceed 1/3. All right, 1/3 of the force that we were able to obtain here. Okay, if the acceleration is beyond this value, then the cable probably will snap. All right, so we are done. Until the next episode, mabuhay, Masya Allah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.